Hey, hi, hello guys. Welcome back to Code with Nani channel. So as I was busy on these days because I need to present my college project as well in the college, and I'm busy with my internship as well. So I couldn't able to upload daily videos from now on. From on, whatever be happens, definitely I'll be uploading daily problems as well as I'll be back with the great content for the basics of DSA on the weekends, on the Saturdays and Sundays. So I'll be uploading two to three videos regarding the basics of DSA on the weekends. And apart from it, daily you will get a lead code problem of the day on my channel. So if you want to get to know get on hands-on experience, can reach from a beginner to the pro level, do subscribe to my channel and hit that bell icon. So let's get into this video. So today problem of the day, count symmetric integers. So you are given two positive integers which is low and as well as high. An integer x consisting of 2 into n digits is symmetric. So if you carefully observe this, if it is not an odd integer, because if it is a multiple of 2 into n, definitely it will be a even length digit. If it is an odd, definitely we can return 0, right? So if the sum of first n digits of x is equal to the sum of the last n digits of x, the nums with an odd digit number are never symmetric. Okay, return the number of symmetric integers in the range low to high. Okay, so if you see here this example, low is 0, high is 1. So as single digit never be a single digit or odd digit number. See, if you observe, let's say 1, 2, 3. So how can you divide it into 2 into n digits? Because we have a odd digit length right here, 3. We cannot divide 2 into n equal to 0. How you can divide? So even if you take 2 into n equal to 3. Now how you can do? If you find n 3 by 2, which gives you in a decimal points, we cannot divide. So our digit length we can directly return as 0, or else we need to calculate whether it is a symmetric or not. So how you can say it is a symmetric? Suppose we have a 1 2 3 1 2 0 3. So we will iterate through its half the digits. Okay, what is the sum? 1 plus 2, that is 3. What is its sum? 0 plus 3, 3. So as left sum and right sum are equal, we can directly say it is a symmetric digit, right? So how you iterate through through its digits? So you can even iterate through using a while loop, which we use in a traditional way, finding or reversing your digits. So we'll just find a count that how many digit we have, and iterate through the half the digits and get the sum, and iterate through other digits, other rest of the digits, and get the sum. But what I prefer is just convert it into a string. Convert into a string val equal to it will become a string, right? 1203. Now you can know string dot val dot length will be the digit, how many digit does it has, right? So through it you can do. And if you want to iterate half the length, just iterate from I equal to 0 to less than n by 2 and get the sum. So how you get the sum? Sum plus equal to val of I minus string 0. So what it does is, suppose if suppose let's say the current string current iteration, the value of the character is 2, minus if you are subtracting with string 0, what will does is string 0, suppose let's say ASCII value of string 0 is equal to, let's say, mm, let's take 120. I don't know exact ASCII values, you can check out on the ASCII table as well. Okay, so let's say ASCII value of 0 is 120, ASCII of 1, that will be 121. Okay, ASCII value of 2, that will be 122. So if we are subtracting the current character of num with the ASCII value of 0, now see, 122 minus 120, which is 2. So that is exactly giving you the value of the digit, right? So that's what we do. So we'll iterate through half the digits and we'll get the sum, and we'll iterate another loop with the another loop with from I equal to n by 2 to the end of the string, then we'll get the sum as well. And finally we will check whether both the sums are equal. If the sums are equal, we will return 1, which means it is a symmetric value, or else we'll return 0. So I'll just walk you through the code. You'll get more clarity, even more clarity around the question. So that's what we're doing. So don't consider this lambda function, just check out this function, check out this for loop, what we are doing. So first initializing with the count as 0. Let's just zoom in. So let's just initialize the count as 0. We are iterating from I equal to low to I less than or equal to high, as they're given the square brackets, which means we need to include high as well. So we are iterating throughout the high, and we are converting the present I to the string. We are just converting string. You know why we are converting string? It is easier to iterate through the digits. We are iterating over the strings. That's why we're now count is equal to count helper of value. So we are just passing this string to the helper function that will return whether it is a symmetric string or not. If it is a symmetric string, it will return 1, so the counter will increment by 1, or else if it returns false, it returns 0, so counter doesn't change. That's what we are doing. So let's just get into the lambda function. So why I'm using lambda function? Because we don't need to use the same parameters like passing this. Suppose if you are using a lambda function, we can, the it is in under the function scope, so all the variables can be accessible. So that's why I prefer lambda function over the function, just standard traditional function. So I'm just passing the string, and the return type of this lambda function is a bool. So I'm just calculating the length of the string, which is n. If at n is an even, you can even write with n percentile to equal to 0, but I do prefer in a bitwise operation, which is even more faster than the traditional way of writing the even or odd values. So if it is an odd, directly return false, or else I'm just maintaining two variables, some and some one. So I'm just iterating from 0 to n by 2, like half the digits, and getting the sum value. You uh, as I already explained you, what does it do? Sum of I minus 0, it will just get the digit value from the strings. Okay, or you can even use this function s to I of s of I, which converts that string to integer. As it is a character, there might be an edge cases. That's why I prefer using s of I minus character of 0. Okay, then we are iterating from n by 2 to nth value, repeating the same thing, getting the sum one value, return sum equal to sum minus 1. So if this boolean value is true, it will return 1. If the boolean value is false, it will return 0. So we're just comparing sum with the sum 1. Okay, if both are equal, it is a symmetric integer. If it is not, then it is not a symmetric integer. Okay, then just submit the code. Voila, it's submitted. And that's it for the today video, guys. Oh, hold on. So before I'm winding up this session, I will just want to explain you the um, time complexity of solution. Okay. So as as we are iterating from low to high, okay, the time complexity will become, sorry, high minus low. Okay, this is one thing. And for each value of I, so for each value of I, we are checking a lambda function. So how, so if you carefully observe, so for each value of I, we are using this lambda function. So what is the worst time complexity of this lambda function? Suppose if you check on the constraints, and value is equal to 10 power 4, that is the maximum value. So we, which is 100. Yeah, this is the 10 power 4. So if you convert this into the string, so how many iteration that you will do? So for first loop, we are going, let's take another, let's take an example of 10 power 5. Okay, so in each first iteration, we'll check for these three values. In the next iteration, we'll check for these value. So the maximum worst time complexity that of that n power 10, like that lambda function will go as 3 times. So for the first for loop it is 3 times, the next for loop it is 3 times, because we only check on the integer, which on the digit part. Okay, so that is 3 into, and so if you take only the linear time complexity, which is high minus low, we don't consider about the coefficients. And if you take the time complexity, if you take the space complexity, as we are not using any other additional data structure, it is one, and that is the time and space complexity of this solution. And so, and that is for today video, guys. So if you find it useful, do subscribe to my channel and hit that bell icon so you never miss any notification from my channel. And that's it for today video, guys. Thank you, tata, bye bye, see you tomorrow with the correct content. Bye bye.